Hi team. So in this video, we are going to talk about the internals of Java HashMap. Now Java HashMap is a data structure which is widely used to store key value pairs. Let's have a look at its internal structure. So internally, the Java HashMap uses an array of buckets where each bucket is a linked list or a tree after certain conditions. So basically, these buckets that you can see over here, this is where the key value pair node resides, and these buckets can be linked list or tree depending on certain conditions. Now, each type of our entry in HashMap is of the type map.entry object. So each type of our entry is of type map.entry object, right? This object contains three things. We have the key value pair, we have the hash code, and we have the reference to the next object. This reference can either be a linked list or it can also be a tree, depending on conditions. Now, let's look at some important concepts of hash maps. So, in hash maps, we have buckets. The buckets are nothing but the place where data is stored. The buckets are an array of nodes. Each bucket holds a list of key value pairs. Why do we say a list? It is because in the case when two keys have the same hash, there would be multiple values stored in a particular bucket. That's why we say as a list of key value pairs. We also have a hashing function. This hashing function is used to convert a key to an integer hash value. We also have collision handling mechanisms. When two keys produce the same hash value as told before, then they are stored in a linked list or a tree. We also have two more concepts, which is a load factor and a rehashing. Okay, so now a load factor determines when a hash map needs to resize. For instance, let us assume that our size of a hash map is 16 and we have a load factor of some percentage such that when the size reaches 12, we need to resize our array. So when a hash map reaches a size of 12, the size of hash map is then increased and then new hashes are calculated for each and every key value pair and they are stored accordingly. So have a look at rehashing over here. This happens when the number of key value pairs exceeds the threshold as given by an example over here. So let's see how things actually work inside a hash map. Step 1. A key value pair is inserted. When a key value pair is inserted, we use a hash function that calculates the hash based on the key, which decides which bucket the key value pair will go in. So you can see we calculate the hash function and calculate the hash based on the key. Now, the hash code function is used to calculate the hash and the bucket is decided using the formula index is equals to hash of key and n-1. This formula will give you the particular index of the particular key value pair. After we have done with the hash function and we have stored the value in the particular bucket, we see that whether there is a hash collision happening. Now, what do I mean by hash collision? So hash collision means that, for example, if we have an array of hash map, basically the buckets, and we see that the hash that we calculated already has a particular value, and now we have to add a new value in it. So in that case, the value will either be stored in a linked list or a tree. So in the case of collision of hash map, the hash map internally handles the collision. And to internally handle the collision, there are two ways. Either we store the data in the form of a linked list. If two keys generate the same bucket index, the second key value pair is added to the same bucket as a linked list. Now, there is also a case where we store the data in form of trees. So if the number of entries in a bucket exceeds a threshold of 8, the bucket linked list is converted into a red and black tree. Now, why do we convert this thing into red and black tree? It is because the red black tree gives us a faster searching operations, which is of log of n. The step 3 consists of load factor and rehashing. Now what happens over here? In load factor and rehashing, when a particular size of a hash map is reached, then the hash map resizes itself. When the resizing happens, there is a step called as rehashing. In case of resizing, the size exceeds a threshold capacity. then the size of the bucket array is doubled and the existing entries are rehashed into a new array. This was how internally HashMap works. Let us look at the time complexities of certain operations. Insertion. So insertion takes order of 1 on average and order of n in the worst case. Retrieval itself takes order of 1 on an average and order of n in the worst case. Same goes for deletion. It takes order of 1 on an average and order of n in the worst case. Now, this takes order of n because of hash collisions. Supposingly we increase a particular threshold, then we have to do rehashing, and in case of rehashing, we have to calculate hash for each and every key value pair. That is why it takes order of n time. This was all about the internals of a Java hash map. Thank you.